Good morning, INTERWEB. It's time to do a bit of follow-up on my last video, Inventing a Number System 2, featuring Conlang Critic. If you haven't watched that video, links in all the usual places, go check it out, otherwise none of this is going to make any sense. Before I get to the main event of 0 to the 0 gate, I want to talk about a great comment I received on r/conlangs, a subreddit you all need to be a part of, links in the description. The comment came from a redditor called GufferDK. It was a really long comment, so I'm going to just abbreviate here slightly. Apologies, GufferDK. The things I want to talk about that they brought up are restricted systems, tens units versus units tens, and esoteric bases. So restricted systems are we kind of sort of touched on them with Piraha, but they are number systems that only have a few specific number words. So think of it like in English as only being able to count up to 20 using specific words, and beyond 20, you just use things like many or more or a lot, that sort of thing. I like to call these kind of like pure restricted systems, but there's also a thing I like to think of as being like semi-restricted, where there are number systems that are fully fledged in the sort of Western sense, in that they have specific words into the tens of thousands, hundreds of thousands, etc. But they don't always use these words. So in everyday life, the specificity stops at like, say, 10, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Everything after that is just many. But in special occasions, like say rituals or certain ceremonies, etc., the more specific large numbers get like wheeled out. And the example that GufferDK brings up is that of a ceremonial yam counting thing that occurs in southern Papua New Guinea, where really large numbers are used, but in everyday life, you don't get more specific than 5. So 1, 2, 3, 4, 5, many, except for when you're doing the yam counting, where you use really, really large numbers. And I suppose the salient point here is that you don't need to be so specific with your conlangs. Like in everyday life, even in our very numerical world, how often do you really need to count that high? Like outside of like say maths and specific measurements like time telling, etc., you're only dealing with small numbers. You know, you're saying things like, I'll have 2 sugars in my tea, please. Or can you pass me an orange? Or give me 2 minutes. Or, you know, that kind of thing, you know? So as weird as these restricted systems may seem, it's not all that weird. And it's a thing you should consider using in your conlangs. So what GufferDK means here by 10 units versus units tens is this notion of like how we pronounce numbers, like what order do we pronounce the constituent parts of numbers. So do you say 26 like in English, tens followed by units, or do you say 26 like in German, units preceding tens? And obviously, you know, when you have hundreds, do you go hundreds, tens, units, hundreds, units, tens? Do you do something like units, hundreds, tens, for example? It's worth checking in with real languages to see what they do. So if you are going to do something trippy, know that you are doing something trippy. Also, and speaking of trippiness, I always think of units as being like affixes. So when I say 26, my brain thinks that 6 is being tacked on to 20 as a suffix. And when I say 26 auf Deutsch, I think that the 6 is being tacked on at the front of 20 as a prefix. So I wonder, and I'm almost sure this doesn't occur in natural languages, but I'm wondering, could you take inspiration from the way in which languages affix things? So when you say 26, could you like circumfix, where you go like 323? You're taking the 6 and you're wrapping it around the 20. I wonder, could you do that? Or could you like infix? So you take the 20 and you like split it apart and you put the 6 inside it. So like 10, 6, 10. Like, that's probably crazy, and there's probably a whole lot of problems with that. In fact, I can think of problems right off the bat now. Like, what do you do when the affix is odd? But, yeah, that could be a thing to explore. It might be fun. Who knows? Esoteric bases. GufferD pointed out that we spent way too long talking about esoteric bases when they're not actually all that useful to the average conlanger. And that's 100% correct. Like the implicit assumption of that video is that we're just going to be number nerds. We're going to tell you a little bit how to work with kind of stranger numbers in conlang, but also we're just going to get nerdy for a little bit. So I fully agree with that. But like people do also make like art langs and philosophical languages, or like languages for like aliens or cyborgs and that sort of thing. In which case it might be an idea to explore those more esoteric bases like negative bases or base 1 or, you know, balanced ternary. Balanced ternary, for example, like I would totally buy alien cyborgs counting in balanced ternary, for example. So it was meant to be us kind of having fun with numbers and being number nerds, but also there is some use in those stranger bases, in my opinion anyways. Okay, the big one. 0 to the power of 0. Just about every man, woman and child on this planet seem to have contacted me to say that, hey, you're entirely wrong. 0 to the power of 0 is not undefined. It's equal to 1. So before I explain things here, Mitch would definitely be at pains were he here now to point out that he had included an explanation of why 0 to the 0 is undefined in a original draft of the script, but I cut that explanation for the sake of time and for the sake of the joke, which I still stand by. I think here is a better place to talk about this, and it made the ending funnier in the main video. So that being said, 0 to the power of 0 is not equal to 1. 0 to the power of 0 is in fact undefined, despite what everyone said, and many of you justify the claim that 0 to the 0 is equal to 1 by saying that anything to the power of 0 is equal to 1. Ergo, 0 to 0 is equal to 1. That sounds legit until you remember that 0 to the power of anything is equal to 0. So I could just as easily say 0 to 0 is equal to 0. It can't be both answers, nor can we arbitrarily choose which power rule to employ here. We have to be a little bit more tactful. So to figure out what actually is going on here, I want to go look at something we all agree on, which is dividing by 0. Dividing by 0 is bad, right? I hope we can all agree on that. It's undefined. Anything divided by 0 is undefined. But why is that? So go to Wolfram Alpha. Strongly suggest you do this with me. Go to Wolfram Alpha and put in the function 1 over x. And you should get a graph that looks something like this. Now to figure out what's occurring when x equals 0, like when we're dividing by 0, we have to take limits, right? You don't need to have nightmares of pre-calculus here. We can do this all visually. It's totally cool. If we take the limit as x goes to 0 from the positive direction of this function 1 over x, we find that the closer and closer we get to 0, the more the function explodes up to infinity. Cool? All right. When we take the limit as x goes to 0 from the negative side, the closer and closer we get to 0, the more the function explodes down to negative infinity, right? Which is problematic. We can't have the limit change depending on our approach, because really quickly we're getting into a situation where we're saying negative infinity is the same as positive infinity, which is just abject nonsense. So we say, look, we're getting different answers here at this point x equals 0. We're just going to say it's undefined, otherwise we'll break everything. Okay? Hopefully that's visually intuitive, and hopefully we all agree on this, okay? So, in order to figure out what's going on with 0 to the power of 0, we need to do the same thing. So go to Wolfram Alpha and put in the function x to the x, and you should see a graph that looks a little bit like this. Same thing as before, let's take the limits. So the limit as x goes to 0 from the positive side is 1. The closer we get to 0, the more we hone in on 1. In fact, at 0, we're at 1. Cool. The limit as x goes to 0 from the negative side is also 1. The closer we get to 0, the more we hone in on 1. And in fact, at 0, we're at 1. So the limit as x goes to 0, regardless of how we approach 0, of the function x to the x is equal to 1. Therefore, 0 to the power of 0 is equal to 1. Except we didn't check all the approaches, because we didn't check all the numbers. Like what Wolfram Alpha is spitting out to us here is just the real numbers. Many other types of numbers exist, like the complex numbers, for example. And if we were to move into the complex numbers, we'd have a whole bunch more ways in which we can approach 0. And if we were to start taking the limits there, which I'm not doing like verbally on camera because it's really awkward, but if we were to start taking those limits, we would find that just like with the dividing by 0 case, depending on how we approach 0, we get wildly different answers. And the moment that happens, we have to declare that that function, when x equals 0, is undefined. So 0 to the power of 0 is undefined. Now, most of you are kind of like, don't care, that made no sense. 0 to the power 0 is equal to 1, that's just the way it is. Okay, fine. Go to Wolfram Alpha and put in 0 to the power 0 and you'll get undefined, okay? Again, lots of you would be like, yeah, okay, fine, I don't care, right? I went to the Google calculator or I went to the calculator on my phone and I said 0 to the power 0 and it told me it's 1. So like, what, are we arbitrarily choosing calculators now? And this is a really good point, and I think this is where the confusion ultimately stems from here, that calculators do tell you it's 1 sometimes. But remember, calculators have their own conceits, and in these edge cases, you need to know what the calculator is actually telling you. So to demonstrate, put in the same calculator it's giving you 1 for 0 to the 0, put in the square root of -1. I imagine most, if not all of you, are going to get an error message right now. But we kind of don't care. We're like, oh yeah, no, I get that. But like square root of -1 is a complex number. It's I know that. Just the calculator isn't dealing with complex numbers. And that's kind of the point. So with 0 to the 0, the calculator is saying, oh, I'm only dealing with real numbers here, so I checked and it's equal to 1. I'm not making any claim that this function holds and is defined always. I just have a limited domain that I am allowed to look at, right? So 0 to the power 0 is equal to 1. Yes, if and only if you're dealing with real numbers. If you use a more powerful calculator like Wolfram Alpha that takes into account a much broader spectrum of number types, you'll get undefined. And I imagine, I haven't checked this, but I imagine if you go to Wolfram Alpha and you put in the square root of -1, I imagine it won't throw back an error. I imagine it will throw back I. Because again, it's taking into account the total, if not the totality, but like close to the totality of different types of numbers. So mathematicians say that 0 to the power 0 is undefined, not equal to 1. There's definitely still going to be people who tell me that it's equal to 1. It's one of those mad edge cases though, like it's that gray area where it's just, there's always going to be some sort of confusion like. But yeah, hopefully I have convinced you, or the videos in the description have convinced you that, yeah, mathematicians say that 0 to 0 is undefined. I've been in this location for too long, so I'm going to go to the other location. See you in a bit. Anyways, that was follow-up from the last video. I really hope you enjoyed. Hopefully I cleared things up a little bit. Also, we're in December, so happy Christmas to one and all. Thank you so much for watching these videos. You have made my year like you make every one of my years. Thank you so much. Enjoy the holidays. Stay safe. See you soon. Until next time, Edgar out.